In permutation that we have discussed in the other video, the order is important in permutation. So in permutation, the order or the arrangement of object is important. However, in combination, the order is not important. Okay? Or the arrangement of object or the arrangement of elements is not important. Example, you can look at this example. Okay? Number 1 and 2. Okay, what example tells us that the order is important and the order is not important? When you say entering the PIN of your ATM card, is the order important? For example, if your PIN or personal identification number is 6137. So usually ATM cards is 4 numbers, right? The PIN of ATM card is 4 numbers, or some have 6, right? So we have 6137. If this is your PIN, what if you are going to enter 1637? When you look at the arrangement, they have the same elements, right? 6, we have here 6, you have here 1, you have also here 1, you have 3 here, you have 3 here, you have 7 here. So, this is your PIN, your original number, your PIN. But you enter 1637. Are these two numbers the same? Of course, they are not the same. Therefore, the number 1 scenario, the order here is important. In entering your PIN or PIN of your ATM card, the order is important. The number 1 is the example of permutation. Okay? However, in number 2, we have here selecting 5 people to form. This is to form a student affairs committee. So you are going to form a student affair committee selecting 5 people. For example, we have student 1, student 2, student 3, student 4, student 5, student 6, student 7, student 8, student 9, student 10. So we are going to select 5 people to form a committee. So we select here student 2, student 10, student 7, student 9, and student 8. There are 5 people and this is one committee. Okay, this is a committee of 5 people. Okay, how about if we are going to rearrange this one, like student 10, then student 2, student 9, student 7, and student 8. If you are going to look at the example, the arrangement here, is not the same with this arrangement, right? However, if you're going to look at this, the question here is just to select 5 people to form a committee. So is the arrangement important in this scenario? If we have here student 2, student 10, student 7, student 9, student 8, we have the same element also here, student 10, student 2, student 9, student 7, student 8. Are these two arrangements the same? Yes, they are the same since we are just forming a committee. It doesn't mean that this one here, the student 10 is selected first before student 2. Here, the student 2 is selected first before student 10. Though they are selected in a random order, but these two arrangements are just the same since this is composed of one committee. This committee is just the same with committee because they have the same people, same element, since the word there is just to select. The word here select only. But you are not going to arrange them in order, but you are going to select them. So you select, so same element, same people, therefore these two arrangements are just the same. This is just the same. Therefore, in number 2, in selecting 5 people to form a student affairs committee, the order here is not important. The order is not important. If you are going to look again, the example here, S sub 2, S sub 10, S sub 7, student 7, student 9, student 8. But here, the order is student 10, student 2. But the question there is just to select and to form a committee. Therefore, these two arrangements are just the same. Therefore, the order in this number 2 is not important. And this is what we call a combination. So what is now the formula for combination? So we have here the formula for combination. Combination of n taken r at a time is equal to n factorial over r factorial times n minus r factorial. Okay? Where your n should be greater than or equal to r, and your r should be greater than or equal to 0. So your r should be less than or equal to n, but greater than or equal to 0. So your r could be 0, but it should not be greater than n, and your n and r would be the same. Okay? So we have here an example. In how many ways can a committee consisting of 4 members be formed from 8 people? So, is the order important here? So, you have to ask yourself if the order is important here. If the order is important, it is permutation. However, if the order is not important, this question is combinations. Okay? So, when you're going to look at the example again, you are going to read the example again. It says here that you can see here that you are going to form a committee consisting of 4 members to form from 8 people. So from 8 people, you are going to get 4 people to form a committee. However, in this example, the order here is not important because you are just going to select whoever that people is. You are going to select whoever the first one you are going to select. Okay, so this example is an example of a combination. So we have here a combination of 8 taken 4 at a time. Since you have your n is 8 and your r is 4, because you are going to take 4 elements from the number of elements, or going to take 4 people in each committee from the 8 people. So, we have here 8 factorial over, your r is 4 factorial, your n is 8 minus 4 factorial, that would be, is equal to, we have here, okay, 8 factorial, 8 times 7 times 6 times 5 times 4 times, okay, until 4 factorial. Because 4 factorial is 4 times 3 times 2 times 1. Okay? So that the 4 factorial here, I can cancel out this one from this one. So, to this one. Okay? So, 8 minus 4 factorial, 8 minus 4 is 4 factorial. So, I cancel this out. Therefore, we have here 8 times 7 times 6 times 5. 4 factorial is 4 times 3 times 2 times 1. Remember that 4 times 2, that is 8, right? So, 4 times 2, that's 8. You can cancel out the 8 here. Then the 3 here, you can have 6 divided by 3, that's 2. So, we have 7 times 2 times 5, 7 times 2, that's 14, times 5, that's 70. So, there are 70 ways to form a committee of consisting of 4 members in a committee from 8 people. Okay?